You know how that idea of like actually living on Mars, it just kind of grabs you.
Oh, absolutely. It's
But then
captivating.
you dig into what it would really take, and it's a lot.
It is a whole different ball game than just visiting.
So today we're doing a deep dive into one scientist's really pretty wild idea for making Mars maybe a bit more habitable.
Yeah, the sources we looked at focus on this pretty radical approach, slamming asteroids into the planet.
Exactly. Sounds like sci-fi, but stick with us. There are some real, wait, what, moments as we unpack this plan.
Definitely. It forces you to think on these huge timescales, even if the practicalities are well way out there.
Okay, so let's get down to it. What are the really big hurdles on Mars? Why do we even need such extreme ideas?
Well, the sources highlight two massive ones right off the bat.
Okay.
First, the soil, the Martian regolith. It's packed with perchlorates.
Right, which are like bad news for humans.
Very bad news. You can't farm in it. You don't want to be breathing dust from it. It's toxic stuff.
Okay, toxic soil. What's number two?
The atmosphere.
Yeah.
Or the lack of it, really. The pressure is incredibly low.
So low that I read something unbelievable about that.
Yeah. If you were exposed without a suit, the pressure is so low your blood would literally boil.
Wow. Okay, definitely not a walk in the park.
Not remotely.
Yeah.
So yeah, you see why people are thinking creatively.
Right. Standard solutions maybe don't cut it. Which brings us to Dr. Leszek Czechowski, Polish Academy of Sciences.
Uh-huh. He looked at some other ideas, maybe using moss or lichen from Antarctica.
Yeah, I saw that mentioned.
But he apparently didn't think those were practical on a large scale. His idea is bigger.
Much bigger. Deliberately crashing asteroids into Mars.
That's the one. It sounds destructive, but there's a specific reason behind it.
Okay, so why? Why bombard Mars? What's the actual goal there?
It's about what's in those asteroids, specifically icy ones.
Icy asteroids. Like comets.
Sort of, yeah. Ones from the Kuiper Belt, maybe, or even further out. The idea Dr. Czechowski proposes is using asteroids from the hypothetical Oort Cloud.
Okay, the Oort Cloud. So the plan is hit Mars with these icy rocks.
And when they hit, the impact vaporizes the ice and releases trapped gases. Water vapor, nitrogen, maybe other volatiles.
Ah, so the asteroids are like delivery trucks for atmosphere ingredients.
Exactly. Because Mars' current atmosphere, as we know, it's super thin, mostly CO2. Totally unbreathable for us.
Right.
So the hope is enough impacts, enough released gas, and you could gradually build up a thicker, more protective, maybe eventually breathable atmosphere.
Importing an atmosphere, basically.
In a sense, yeah. Using resources from elsewhere in the solar system.
And you mentioned the Oort Cloud as the source. That's really far out, isn't
But
it?
extremely far. Way beyond Neptune. It's this theorized giant sphere of icy objects surrounding the whole solar system.
And the sources said it potentially holds how many?
Trillions. With a T.
Right.
An almost unimaginable number of these icy bodies.
Trillions. Okay, so the raw materials are theoretically there in abundance.
Theoretically, yes. Plenty of ice and gas locked up out there.
There's always a but, isn't there?
Oh, yeah. A huge one.
Getting one of these things from the Oort Cloud all the way to Mars.
The article we looked at crunched some numbers based on current or maybe near future conceivable tech.
And the travel time estimate was?
15,000 years.
Hold on. 15,000. 15000.
Yep. 15,000 years per asteroid, presumably.
Wow. Okay. That just changes everything, doesn't it?
Completely reframes it.
This isn't a plan for like our grandkids. This is deep, deep future stuff.
Absolutely. We're talking timescales that are hard to even grasp in human terms. More like geological time.
So forget near-term colonization using this method.
Definitely not a quick fix.
Yeah.
Dr. Czechowski's idea, it's clearly positioned as a potential path for the very distant future of Mars.
Thousands and thousands of years down the line.
Precisely. It makes you question the immediate practicality, of course.
But the sources still frame it as, a possible pathway, despite the crazy timescale.
Right. And that word possible is key. It's highly speculative. It acknowledges the enormous challenges the tech needed, the time.
But it's an example of thinking big, tackling the root problem.
Exactly. It shows, the kind of ingenuity being applied to these massive habitability challenges. It forces you to consider options on a truly planetary engineering scale.
Okay, so let's sort of wrap our heads around the core takeaway from this deep dive.
Fundamentally, it's using impacts from icy asteroids, likely sourced from the incredibly distant Oort Cloud.
To deliver gases, water, nitrogen, etc.
Right, to slowly, over millennia, build a denser Martian atmosphere,
Yeah.
addressing both the pressure problem and maybe eventually the composition.
And it's presented as one potential long-term strategy, contrasting with maybe smaller scale, nearer term ideas.
Correct. A very ambitious, very long-term one.
That 15,000-year figure just keeps echoing, though. It's mind-boggling.
It really is. It forces you to think about what long-term planning could even mean on that scale.
Yeah, it's beyond infrastructure projects or, societal goals we normally discuss.
It truly pushes into the realm of species-level, multi-generational, maybe even evolutionary timescales.
So, okay, final thought then. If we're seriously contemplating projects that take 15,000 years,
Uh-huh.
forget the tech for a second. What does that kind of timescale imply about us? About humanity's actual commitment or maybe just ambition to become multiplanetary?
That's a fascinating question, isn't it? What kind of future are we even imagining if our plans potentially stretch that far?
Yeah. What kind of legacy does that represent? It really makes you ponder our place, not just on Earth, but potentially out there across vast stretches of time.
It certainly does. A lot to think about.